All right. So now, how can I find, you can see in the question it says, if x is equal to -3 is a root of this particular equation. Now, they are now asking you to find the other roots. Now, this one will give us a clue on how we can actually deal with it. There is a two-way we can actually solve this particular problem on the board. So the first one is by converting this rule that you are given. We firstly convert it into factor. Now, how can we convert it into a factor? So by send it inside, that will be x plus 3. So now, if it is x plus 3, this thing that we have here is actually what we mean by a factor. It's already a factor, it's a factor already. So now, the next thing I'm going to do is that I can easily, we have a divisions of a polynomial, we have multiplications of polynomial. Of course, we've already done one of multiplications of polynomial. Like, if you have, like, let me take for instance, what we mean by multiplications of polynomial is when you have maybe like s plus 3, maybe like s plus 5. Now, you are asked to multiply them together because this one is a polynomial, this one is also a polynomial, this one is also a polynomial. This is what we mean by multiplications of polynomial. This is what we mean by multiplications of polynomial. So now, if I have something like this now, you can easily, you know how we can multiply it. That will be multiply this one by this one. Let's multiply this also by this, this by this, then plus what? Plus 15. So it will be s squared, 5s plus, then plus what? 8x, then plus 15, then plus 15. So this is what we mean by multiplications of a polynomial, and we can see that we get another polynomial. So now we are going to do something, we get another polynomial. So now we are going to do something, divisions of polynomial here, for us to be able to solve this particular equation. If you want to get the other factor, what you are just going to do here is that by us dividing it, because so far we've already gotten one factor of this particular equation. For us to get the second factor, we can divide it with this, and it's going to give us the polynomial. So now, if I have a polynomial, let me give us one simple tips that can help us. So polynomial p of x is simply, maybe if we divide polynomial p of x by divisor d of x. So now this thing will just give us what we call a q of x, then plus what? Then plus remainder of x divided by divisor of x. All right, so now this q of x that we have here is what we call a quotient. So this is what we call a quotient. This is a remainder divided by divisor when we divide the polynomial p of x by d of x. Once you understand this, we can easily perform divisions of polynomial very easy. Now, let's take this one for example now, so you can understand better what I'm trying to say. So now we've already got to divide it by this, so we can get the other factors of this particular equation. So let's divide. We are going to say that, oh, this x squared plus 5x plus 6 divided by, what is the one factor that we've gotten earlier? S plus 3. So divided by s plus what? S plus 3. So if you have something like this now, what you are going to do here is what we call a long division. We always call it long division. Now, what do we mean by long division is this. What do we mean by long division? Is by us saying something like this. So, what we want to divide, the polynomial we want to divide, we can easily place it here. So, if we place the polynomial here, that is s squared, then plus what? Plus 5x, then plus 6. So, and what we are dividing it with, which is the divisor, we can place it, we are going to place it at this point. That is s plus what? S plus 3. So now, if you have something like this now, from here, we can easily, at this point, this is where your q of x will be. Like this, let me write it here again. We are trying to put our d of x here. So we are putting d of x here. We are putting polynomial p of x here. This is where all your q of x will be. Then your remainder will now be at this point. So now, if you want to do this, from here, we can easily, the way we are going to multiply it, see how it's going to go, because you need to understand it as far as JAMB is concerned, they will ask you. So now if I have here now, what can I use to multiply this? Because what you are trying to do here is to cancel. This, so we can reduce it a little bit till we get to where we are going. But now, if it's only a quadratic you are giving, if it's quadratic and it's not a cubic or raised to power 4, raised to power 3, and so on. If you are giving something like this now, if x equal to 1 is a root of the equation, x raised to power 3 minus 2x squared minus 5x plus 6. They are now asking you to find the other root. Now, how can you find the other root in this case? Now, the way we are going to do this is actually by, the only way you can do this, although there are 2 ways if you are very good also, you can use 2 ways, 3 ways, or different way that you want to use. But now, let me just give us a how you can solve this very easy by using our long division here. So I told you in the other time that, because if you substitute this now, for you to confirm that this guy is a factor of this, I told you that you just substitute this root inside the equation. By substituting 1 inside this equation, it must give you 0. So you can know that, oh, this x is equal to 1 is a factor. Because in some scenario, they can just ask you that, is x equal to 1 a factor of this particular? So it's by you substituting the root that you have here, substitute it, test it. If it returns 0 after you substituted everything inside the equation, then it's actually a factor of that equation, of that polynomial. Now let's find the other root that we have here. How can we find the other root here? I told you, let's make this one x is equal to 1, which is the root, turn it into factor. So if I turn it into factor, I can say send it into here, it will now be x minus 1. So this x minus 1 is a factor of this particular polynomial. So now, if it's a factor of this polynomial, long division, for us to get the other 2 roots, we are going to use long division to get other 2 roots. Now, and how can we do that? How can we do that is by saying x minus 1. Now we put x minus 1 here, which is the divisor. Then we put x raised to power 3 minus 2x squared minus 5x plus what? Plus 6. Because I told us in the other time that polynomial p of x divided by divisor d of x is simply quotient q of x plus remainder r of x over d of x. Okay, so now we are going to turn this equation into that now. Then we see the remainder that we are going to get. All right, I told you the quotient is the one that will fill this particular place, while we see how we can perform a long division now. So now, the main thing that you are going to focus here is this. Now you will look here and say that, oh, what can I multiply by x that can actually subtract, if I multiply it, that can be the same value with what I have here. So I can subtract it, then they will cancel each other. Now let me do the first one. So I want to cancel s cube. I want to cancel s cube. What can I multiply with s cube that will make it to by s squared? So if you now perform it now, then s times s cube, right? So s cube. So now if it's s cube, s squared multiplied by minus what? Minus s squared. So you'll do this. Now the next thing is that you subtract it from each other. So for us to be able to cancel what? Eliminate s cube. So s cube minus s cube, that will be 0, right? So now that will be minus 2s squared minus this. Minus 2s squared minus 2s squared minus this. That will be minus 2s squared plus s squared. Minus 2s squared plus s squared will simply be what? Will simply be minus s squared. This is what I mean by that. Minus 2s squared is here. Minus 2s squared minus will give us plus, then plus s squared. So if you simplify this equation, that will be minus 2s squared plus s squared, right? So minus 2s squared plus s squared, that will be minus s squared.